Polyatomic ions. So up to this point we've dealt with monoatomic ions like copper 1+, sodium 1+, magnesium 2+. So it only involves one element. Here we're dealing with polyatomic, poly meaning more than one. So nitrate, sulfate, phosphate also contain the element and oxygen. Cyanide, Cn-1, hydroxide, OH-1. So they all have a charge, but they're also made of at least two different atoms. One of them, this is hydrogen carbonate, actually contains three different elements. And they all will have a set charge. There is a positive ion, and that is called ammonium, and that is NH4 with a 1+ charge. Okay, naming rules are pretty straightforward. An ionic compound, you name the metal first, and then you follow it up with the polyatomic ion. There's an exception to this, and that is if the structure involves ammonium. Ammonium will go first. So, for instance, if we have NaNO3, well, this would be sodium, that's our metal, and NO3 is our ion, our polyatomic ion, and that is called nitrate. We don't call it nitrogen trioxide, we give it its own unique name, and that's nitrate. CaSO4, this is calcium sulfate. SO4, 2 negative, is calcium sulfate. If we have NH4Cl, we've got ammonium. Don't forget that the anion ends in IDE, so this is chloride. You can sometimes have ammonium with another polyatomic ion. So let's say NH4NO3 would be ammonium nitrate. So use your reference table for your polyatomic ions for naming your compounds. So writing formulas, either use your cross and drop or the zero-sum method. I'll do cross and drop first. So cross and drop first. So let's say we have sodium hydrogen carbonate. So sodium is Na, and then hydrogen carbonate is HCO3. So the charge on sodium is always +1. The charge on hydrogen carbonate is always -1. So these numbers are the same. So when they cross and drop, they cancel each other out. So this means the formula is NaHCO3. Magnesium sulfate. So write the symbols. So Mg, and then sulfate in the table is SO4. It has a charge of 2-, and magnesium has a charge of 2+. So we've got 2+ and 2-. They're the same number, so they're going to cancel when you cross and drop them. So it's just MgSO4. Now, what if we do, let's just move this up a little bit. Potassium. Oops, I almost wrote the symbol. Potassium. Phosphate. So potassium has the symbol K. Phosphate has the symbol PO4. We get that from our table. Phosphate is 3 negative. Potassium is 1 positive. So these numbers are not the same. So when we cross and drop, the 3 crosses over and drops down, and the 1 crosses over and drops down. Don't forget, we don't write ones. So the formula becomes K subscript 3, PO4, and then we're done, because there's only one PO4. And we'll do another one. Okay, ammonium carbonate. So ammonium is not an element, it's a polyatomic ion. So it is NH4. Carbonate is also not an element, it's a polyatomic ion. So it is CO3. Get these from the table. Charge on carbonate is 2 minus. Charge on ammonium is 1 plus. They don't have the same number, so they don't cancel out, so we do have to do cross and drop. So we end up with NH4 with a 2 and CO3 with a 1, but we don't write the runs. Now, this makes it look like there's 42 hydrogens. So what you do when you drop the subscript is you put, if it's a polyatomic ion that has a subscript now, you put the polyatomic ion in brackets. So it's bracket ammonium, bracket subscript 2, carbonate. So ammonium carbonate is this. So put polyatomic ions in brackets if there's more than one of them in the formula. You know if there's more than one because of the subscripts. Here's another example where you're going to have a subscript with a polyatomic ion. So magnesium nitrate. So this is Mg, this is NO3, and the charges, this is 1 minus, this is 2 plus. They're not the same, so we do have to do cross and drop. So the 1 is going to go with the magnesium, the 2 is going to go with the nitrate. So Mg, and then NO3, and there's 2 of them, but it looks like there's 32 oxygens, so you put the nitrate in brackets and then the subscript 2 afterwards. Okay, now I'll show you how to do it using the zero-sum rule. So sodium, hydrogen carbonate. So the charge on carbonate is 1 minus, the charge on sodium is 1 plus. They add up to give you 0, so the formula is NaHCO3. Magnesium sulfate. Set up your T-chart. The charge on sulfate is 2 negative. The charge on magnesium is 2 plus. Did I say that right? Sulfate is 2 minus, magnesium is 2 plus. So the numbers add up to 0. So the formula is just the symbols. potassium phosphate. Potassium and phosphate. So the charge on phosphate is -3. The charge on potassium is +1. These do not add up to be 0. You would have to multiply potassium by 3 to get 3 plus. Now the numbers add up to 0. 3 plus and 3 negatives equals 0. Whatever you multiply by, that becomes your subscript. So the formula for this compound is K3PO4. So the multiplier becomes the subscript for that ion. Okay, ammonium carbonate. So ammonium is NH4. Carbonate is CO3. Now the charge on carbonate is -2. Ammonium is +1. These do not add up to 0. So you multiply ammonium by 2 to give you 2 plus. 2 plus and 2 negative add up to 0. So your multiplier becomes your subscript. However, you've got to put your polyatomic ion in brackets, then put the subscript in, because otherwise it's going to look like you have 42 hydrogens. So you put this in brackets and you put a 2. You don't have to put brackets around the carbonate because there's only one. If there was more than one carbonate, if there had been a multiplier, then you would have to put carbonate in brackets. Magnesium nitrate. So magnesium and nitrate. So nitrate is 1 negative, magnesium is 2 plus. These don't add to 0, so if we multiply the smaller one by the bigger number, now we have 2 negative and 2 plus add to 0. This becomes our multiplier. So our formula becomes Mg, and there's 2 NO3s, so you put it in brackets, and the subscript 2, because I need 2 nitrates for each 1 magnesium. So always the polyatomic ion goes in brackets if it has a subscript.